Hey guys, how you doing? Just welcome to another wee video where I'm going to go through a couple of questions. Now the questions I'm going to do here are all log questions, and actually apart from one, they're all very unusual log questions. They're just stuff that's been posed to me over the kind of past week or so. Just a couple of tricky log questions. Now three of these are from just the 2000s, so it's been a while ago since they've been asked, back when I was a boy. But what we're looking at now is really in your exam, you want to be able to answer three different things. You want to be able to deal with the graphs, you want to be able to deal with the log laws, like when you add together two logs of the same base, you just multiply, and you want to be able to deal with questions, the regular questions that look like this. If you can do that, you will hit 90-95% of log question, the marks in log questions. What I'm going to do now is just go take you through a couple of unusual ones. Okay, so in this one here, 11a, sketch a graph of y equals a to the power x plus 1, where a is greater than 2. The first thing I'm going to look at here is just the graph of y equals a to the power of x. Okay, I'm just going to have a wee sketch of that now. Just bear with me. It's going to look something like that. We know that it goes through 1 on the y-axis and the point 1a. Okay, so when that power there is 1, it's just, we're going to get the y coordinate as a. So that's the graph we're working from. Now what we're going to do is to draw this graph here, we're going to do y equals a to the power x plus 1. So it's going to be exactly the same graph, but it's going to have moved up one place. Okay, so it's going to be exactly the same graph. That's not quite exactly the same graph, but we'll deal with. Okay, and that point there is going to still be 1 across, but it's going to be a plus 1 up. This point here, instead of being at 1, is going to be at 2. Okay, so that's your first mark there. Okay, just for drawing that purple graph correctly. 2 seconds, clear this up. Okay, the next one, on the same diagram, sketch the graph of y equals a x plus 1. Very similar kind of thing going on here. It's probably worth noting though that that plus 1 is no longer at the end added on, it's in there, which is the same effect as putting it inside the bracket. So that plus 1 there is going to move the whole of this red graph one place left. Okay, so this isn't going to be at 1a anymore, it's going to be at 0a. So it's just going to be a on the y-axis. This point here isn't going to be at 0, 1, it's going to be at negative 1, 1. Okay, so it's going to be down here somewhere. And it's going to look pretty much the same. It has a terrible drawing, just bear with me. Okay, it's going to be at negative 1, 1. Okay, so the two key points are negative 1, 1 and the point A. And because here A is greater than 2, that will have to be above your first question, specifying that has to be on the same diagram. Now part B is prove that the graphs intersect at a point where the x-coordinate is log to the base A of 1 over A minus 1. Okay, so we know the point of intersection. So it's a to the power x plus 1 is equal to a to the power x plus 1. And that there, that's going to get you the first of the three marks. Okay, sorry, the second mark in there just for that green graph. There, we're drawing a hell of a lot nicer than what I've done there. Okay, so that's your first mark there. What you're doing after that is a bit tricky. Now, there's nothing you can really do here. The x you're looking for is in the power, so that is very typically when you do a log of both sides. But this plus, it really won't make any difference. Because of that plus 1 there, it makes it a bit messy. So what we're going to do is actually going to use our laws of indices. Okay, this is an A where the powers have been added. And we know that happens when you have multiplied together two different things. So a to the power x multiplied by a to the power 1. That is what happens when you add a power. So we can undo that there. Okay, so that's going to be a to the power x plus 1 is equal to this. Okay, that's actually what gets you your second mark there. Okay, and then, sorry, what we're going to do is we're going to take away a to the power x from both sides, just to get all my a to the power x on one side. Okay, so that's what's going on there, and now we have a common factor on this side. So it's a to the power x can come out, and then you've got a minus 1 is equal to 1. Okay, now we're starting to look a little bit nicer now. That a to the minus 1 is part of my answer, so we're on the right track. And then we can divide by that a to minus 1, and we've got it really nice. That is exactly what's in our answer. Okay, and then just we want it as a log form, so we're going to rewrite that as a log. So it's log to the base a of 1 over a minus 1, so big bracket, is equal to x. And that's you proved your thing there. Now it is tricky and it is very unusual, but starting off your simultaneous equations, that's where your first mark is. Being able to split up that a to the power x plus 1 into your two different things, and then taking out the common factor and rearranging to give your answer gets you your third mark. Okay, very unusual question, quite tricky, but there she is there. Okay, the second one is claimed that a wheel is made from wood, which is over 1,000. It's 1,000 years old. To test this claim, carbon dating is used. This is your formula to determine the age of the wood. For the wheel, it's found that ATT is 88% of the amount of carbon in a living tree. Is the claim true? So we're checking it, is it over 1,000 years old? Okay, so there's a couple of ways to do this. You could check how much carbon would be left after 1,000 years, or you could check how many years it takes for it to become 88%. I'm just going to go that way. Okay, so we want to check how many years does it take to become 88% of the carbon, and from that answer, is it over 1,000 years? So my formula is a to the t is equal to a naught e minus 0.000124 t. Oops, slipped. Okay, and we want to know what happens when it's 0.88 of what we started with. Now I'm going to sub in 0.88 a naught. Okay, because what we really want to know is how long it takes to get 88% of what's left. So we want to know, really cancelling out those a naughts, just divide both sides by a naught, they'll disappear. We want to know when that exponential is equal to 0.88. Okay, and then we're just doing a straightforward solve, so it's going to be a natural log of 0.88 is equal to negative 0.000124t. So the time is going to equal ln 0.88 all divided by negative 0.000124, which comes out at, well, to the nearest year, it comes out at 1,030 years. Okay, you go back to your question. Is the claim true? Is the question? We've not answered that yet. We've just done all the work, so make sure you're answering the question. It is claimed that a wheel is made from wood which is over 1,000 years old. Okay, well, for it to be 88%, like the thing we're given, it would have to be 1,030 years old. Okay, so then we do our work in yes, claim is true, because blah, 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 and so just your communication mark at the end. Okay, so nice question there, very kind of typical of what we look at with this sort of question, but turned around a little bit because you're asked to kind of support the claim that's made. And again, you can come at that from two different ways. You can check how many years it takes to get to 88%, or you can see how much carbon is left after 1,000 years and make your decision from there. Okay, question 8 here. I think this is from 2007 paper. The curve with equation y equals log x minus 1 to the base 3 minus 2.2, where x is greater than 1, cuts the x-axis at the point a naught, find the value of a. Okay, so a very kind of stereotypical starting point for this. We're looking for where it cuts the x-axis, so for our equation y is equal to log to the base 3 of x minus 1 minus 2.2. We're looking for when y is 0. Okay, and then we are going to, that's a 2.2 badly written. Okay, so first thing we're going to do, well, let's add 2.2 to both sides to get that log isolated. And then we've got a single log term equal to a number, so we can rewrite that as an exponential function. So it'll be 3 to the power 2.2 is equal to x minus 1. So x is equal to 3 to the power 2.2, add 1. This will almost certainly be a calculator paper. If it's not, then you'll just be leaving it there. Take that in your calculator, that'll be 12.2. Okay, so subbing in your 0 is going to get you 1 of the marks. Rewriting as an exponential, solving and then from there. Now this where x is greater than 1, that's just administration, okay, because we know we can't take the log of anything 0 or below, so that's just a wee bit of admin there. Okay, and the last question, a radioactive substance decays according to that formula. Okay, Mt is equal to m naught e to the minus 0.004 t, and we're looking to show that the time taken for the substance so is half its mass. So this line written up. This show that the time taken for the substance so is half its mass can be written as t is equal to 250 log e to the base 2. Okay, so really important thing, we're looking for half its mass. So this m naught is what it started with. We're looking to get half of m naught. Okay, and remember that's not the only way to do it. If you wanted to just choose nice easy numbers like 150 and place them in, that's fine. The important thing is that you end up with a half is equal to e to the negative 0.04 t. Okay, and this is a very similar question to the last one in terms of the process. It's just you're going to have to be clever about your rearranging just to get it as it wants it to get there. Okay, so the first thing we've been doing is getting rid of this e by using the natural log. Because they're writing it instead of natural log like that, I would just write it instead of ln, just log to the base e of a half. Now, I think it's very unlikely that it would take marks off you for that, but I'm just going to make it look like the question is here. So this log to the base e, that is a natural log, it's just written in a different way. And that's us kind of starting off our working. The next thing is to divide by negative 0.004. So you're doing log to the base e of a half divided by negative 0.0004 is equal to t. Okay, so that's our first kind of steps. And now what we're going to do is try and make it look like it's 250 log 2 to the base e. Okay, so a couple of things we need to do. Firstly, this 0.004, well, 0.004 is actually the same as 1 over 250. Okay, just like you think of 0.4 as 40. Excuse me, sorry, I started chatting obviously, so I'm just going to redo that. So 0.04 is 1 over 250. Okay, that's 4 over 1,000 when it's 0.04, and then just divide both of them by 4 is 1 over 250. Okay, and because that's 1 over 250, you're really doing divided by 1 over 250, which is the same as times them by 250. So this is really another way of writing negative 250. Sorry, I'm having a bit of a nightmare here with this stuff. Okay, that is negative 250 log to the base e of a half is equal to t. Now, we're starting to get there. It's 250 log e to the base 2. Now, the difference here is that negative at the front. We know if we've got a number at the front, we can move that to the power. So we're going to do log e, we're going to take that negative and make it a power at the back. Now, a half to the power negative 1. Remember, a negative power means you're going down to the bottom, so that's 1 divided by a half, which is really 2. So 250 log to the base e of 2 is equal to t, and that's you showing what they want you to show in the working. Okay, again, it's not a very typical question. Your solving at the start is very typical, doing your natural log and dividing by negative 0.04, but that wee bit at the end with the rearranging is just kind of a bit putting you on the spot with a mathematical manipulation. Okay, that's 4 log questions done in there. I know that wasn't the neatest and the cleanest thing I've ever done, but what the hell, it's Sunday night. Give me a shout if you need any more help with it, if you want me to do anything else. I'm going to do a derived functions lesson over the next day or two. If there's anything else you want me to do, give me a shout. Cheers.